Alright, so today we're starting off Unit 1 with translating expressions. Here we have a nice graphic organizer that's going to come in handy because it outlines a lot of the vocabulary that you're going to use when translating, so words that signify different operations and symbols, and these are all things that you definitely want to be familiar with. This is posted in the blank notes in the Unit 1 calendar if you want to take a look at that in further detail. So the first thing that we want to be aware of is different types of expressions that we're going to be dealing with. But before we talk about that, we also want to make sure that we know what some other words mean. So variable is a letter or symbol that's used to represent a number. And this phrase a number is important because we're going to see this a lot, and this is what we're going to take out and replace with the variable x, n, a, really whatever variable you decide to use. Then we also have the 4 different operations, and there are going to be a lot of words that can be found in that organizer that are used to simplify those 4 different operations. The first type of expression we're going to be looking at is an algebraic expression. This is an expression that has numbers, variables, and operations. So this is the one that looks like math. Okay. Then we also have the verbal expressions, and these are equivalent to the algebraic expressions, but these are written with words instead of numbers and symbols. So for example, we could have triple a number increased by 5 as a verbal expression. So we want to start just by taking these verbal expressions and going to algebraic. And usually when we see these, there's only going to be 1, maybe 2 right answers. So we have 10 decreased by a number. And the first thing that stands out to me is that phrase, a number. This is where my variable is going to go. We have 10, decreased by means subtraction. So my final expression is going to be 10 minus x. Next, we have double a number, increased by 5. So I have that a number piece again. That's where my variable goes. Double means we're going to multiply by 2. Increase by means we're adding. We're adding 5. So we're always going to follow the pieces in the order that they're written, unless there's a word that tells us to flip things around. So we have 2x plus 5. Last, we have a number less 3 doubled, and we've got a comma in here. So this comma means that everything before the comma has to happen before I can do the doubling. So we have a number less 3, and we're going to double it. Now we want to make sure that that x minus 3 piece comes first. So in my final answer, I'm going to put parentheses around it, because if we think about the order of operations, that comes first. And we can put the 2 on this side, or we can also put the 2 out in front. And this is probably the more common version you'll see of this expression. Some tips that you want to keep in mind when we're translating. We have 3 words that tell us that we're going to change direction. Than, from, and to all mean that we're going to take the piece that's on the left and switch spots with the piece on the right. So 7 less, even though it comes first in my sentence, is actually going to move to the end, and a number is now going to come to the beginning. So we have our number, and we take 7 less than that. Of blank and blank is going to be used with our 4 operator words, so sum, difference, quotient, and product. We're going to look for those in the sentence as soon as we see one of these 4 words. And is going to be where my symbol goes. So when I look for difference, I link it up to and. Difference means we're going to be subtracting. Then the 2 pieces on either end of the and are what I'm subtracting. So this is going to be n minus 5. When we're going from algebraic to verbal, there's going to be a lot more variation in the answers just because we have so many different words that mean the same thing. So here I could say 3 times a number decreased by 5. But that's not the only way I could say it. I could also say, let's see, I could also say 5 less than, triple a number. And there are many other ways that we could write this as well. If we look at our next one, we have 8 plus x over 5. So we could say 8 increased by a number divided by 5. We could also say the quotient of a number and 5, added to 8. We've got that 2 in there that tells us we're going to switch direction. So go ahead and pause the video and see what you can get for the other two expressions. Alright, so if you look at the first one, we've got -3 and then that expression in parentheses. So I have -3 times the sum, which lets me know that all of this needs to be done by the time I multiply by -3. Then for the bottom one, we have quadruple a number decreased by 2. The comma tells me that that's going to be done first, and then we divide by 7. You may have written two completely different sentences and they could still be correct, so there's going to be lots of different options here. Our last slide is probably the most important because this is what we'll use the most often. So we're going to be given these real-world problems that we're going to solve using expressions. So you decide to go play a few rounds of Topgolf at the driving range. The cost to rent your bay is $35 per hour, but you must also pay $5 for a membership card. So the first step that you want to do is define a variable, because if I just start writing an expression with a variable in it and I don't say what it is, it's going to be confusing. So the variance here is going to be the number of hours that I play. So I'm going to say h equals hours. My expression, since it's $35 per hour, I have 35h plus that $5 that I pay for the membership card. And usually we'll have some type of question attached. So now we're going to use our expression to determine the cost of 3 hours at Topgolf. And this is why it's so important to define our variable, because now I know where to put that 3. Anywhere I see an h for hours, my 3 is going to go in that spot. So we have 35 times 3. We go ahead, we do some reducing here. We get 110, and then we make sure that we give our answer with units.